Kinematics by Hassan Malik. Rest and motion. Rest. An object is in rest when it does not change its position relative to its surroundings. Motion. An object is in motion when its position changes over time relative to its surroundings. Absolute rest and motion. According to Newton, absolute rest and motion is when a body at rest will remain at rest and a body in motion will remain in motion always. Relative rest and motion. According to Albert Einstein, rest and motion is relative. It means a body at rest can be in a motion and a body in motion can be at rest at the same time, as it depends on the position of the observer. Types of motion. There are three types of motion. Translatory motion / linear motion. Motion in which all parts of an object move the same distance in the same direction and in the same interval of time. Example, car driving down a straight road. Rotatory, or known as circularity motion. Motion in which an object rotates around a fixed axis. Example, a spinning top. Vibrating motion, also known as to and fro motion. Motion in which an object moves back and forth about a fixed point. Example, the vibration of a guitar string. Position, a place or point where someone / something is placed or located in relation to other things. Distance. Distance is the total length of the path traveled by an object, measured in a scalar quantity. Displacement. Displacement is a straight line distance and direction from the initial to the final position of an object, measured in a vector quantity. Displacement equals final minus initial. Time, the dimension in which events occur sequentially, measured in seconds, minutes, hours, etc. Speed. Speed is a scalar quantity that describes how fast an object is moving. It is defined as the distance traveled per unit of time. Speed equals distance divided by time. Velocity. Velocity is the speed and direction of an object's motion. It is a vector quantity. Velocity equals displacement divided by time. Acceleration, the rate of change of velocity per unit of time. Acceleration equals velocity divided by time. Jerk, the rate of change of acceleration with respect to time. Jerk equals acceleration divided by time. Scalars and vectors. Scalars have magnitude only, while vectors have both magnitude and direction. Distance time graph. A distance time graph represents how an object's distance changes over specific time intervals. Distance time graph represents velocity. Velocity time graph. A velocity time graph shows the variation of an object's velocity over time. Velocity time graph represents acceleration. Acceleration time graph. Acceleration time graph shows how an object's acceleration changes over time. Acceleration time graph represents jerk. Conversion from meters per second and kilometers per second and vice versa. Newton's law of motions. There are 3 Newton's laws of motion. First law of motion, a body at rest remains at rest and a body in motion remains in motion, unless and until an external force acts upon it. Second law of motion. The acceleration of a body depends on 2 things, force and mass. The more we apply force, the more the body will accelerate. Direct relation. The more the body has mass, the less it will accelerate. Inverse relation. Third law of motion. For every action in nature, there's an equal and opposite reaction. If object A exerts a force on object B also exerts an equal and opposite force on object A. In other words, force results into interreactions. Kinematics with philosophy. Kinematics with astronomy. Formulas associated with kinematics. Displacement equals final minus initial. Speed equals distance divided by time. Velocity equals displacement divided by time. Acceleration equals velocity divided by time. Jerk equals acceleration divided by time. And force equals mass times acceleration. Units associated with kinematics. The end, and this is a flowchart of kinematics. Thank you for watching.